Hello everyone. After doing a series of talks on computer vision, the team of SciTech Talks is back with a podcast on MLOps for beginners. MLOps is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. There is a lot of emphasis these days on using MLOps by many organizations, and in order for the students to be industry ready, it would be useful and essential for them to gain enough experience and incorporate some of these MLOps principles into their machine learning projects. But what is a starting point to learn? Or among various tools that exist today to assist ML model development, which one to prefer? Or if you have any such similar questions, this podcast is absolutely for you. Our team at SciTech Talks today are delighted to host Mr. Abhishek for a podcast on MLOps for beginners. Abhishek is currently a machine vision expert at Flutura Decision Sciences and Analytics. He is GSOC Scholar and won the prestigious award called Influential Data Scientist of the Year 2020 by International Society of Data Scientists. His prime research interests include optimized edge development and building low-code tools for the end-to-end lifecycle management. With such credentials, Abhishek will be answering some of the most fundamental questions that many beginners of MLOps would have. Without wasting much time, let's hear from Abhishek about his story and what advice he has to say for budding data scientists.
Story as a normal data scientist that exists in this field, in a day-to-day field. With regards to image processing, I was very lucky because I started my graduation with electrical and electronics engineering at BITS Pilani. And I was like, as I said, I was very lucky to get some good seniors who introduced me towards image processing via robotics. Because back in 2012 and 2011, robotics was a field which, I mean, AI ML as such hasn't picked up a great trend then. So robotics was something like every electrical engineer would look towards. So same as me, I joined the robotics club. Then the vision system of robotics like intrigued me a lot because I'm sort of a person who relates to results being seen rather than just things happening. I mean, if you take up a simple electrical or electronics field, you do something to a circuit board, something happens. But with regards to image processing and computer vision, if you do something to a video or an image, you can see what exactly is going to happen or what happened with that image. So from there, my journey started. I started working with my fellow seniors on different types of robots like hexapods, quadcopters, and their vision systems, just to basic image processing things. Then I was fortunate enough with the college that they allowed us to do internships while we were studying, like remotely, or even if we wanted to go there. So then I started doing internships in different domains, like retail, then on the lines of 3D image processing, then with the lines of there was a startup in Japan. There's a startup in Japan, Aeonics face recognition. So they completely focus on face recognition systems. So I was lucky enough to work under the founder there, Dr. Sadi Vural. Then there was an Italy-based startup which was working on 3D space reconstruction in the dome, I mean, in the houses and everything. Then one very good startup that I worked was Tesseract Imaging. At this point, it's acquired by Geo and it's called Geo Tesseract. So there, the goal was they were preparing a 360-degree camera at that time. And then I was introduced to the concepts of machine learning, the stereo vision, the photogrammetry space, and all that. And from there, I think the journey kicked up with ML coming into the play, neural networks, CNNs coming into the play, and that like increased my interest completely. So I did my thesis with Tata Elxsi on self-driving cars. And with those, while I mean, doing internships and startups and moving to an organizations, there was a complete shift for me where I learned about exactly the process. I mean, from there itself, they had this concept of ops, like not ML ops as such, but ops and coding and how a thing should be created, how a thing should be worked on. So there, the research and the work and everything took me to a complete different phase of my journey. I worked there for an year after completing my thesis, and that was it. And suddenly, a few of my friends came up, and they were like, "We are coming up with a startup." Entrepreneurship is something not that I wanted to get into, or like like most of the entrepreneurs have that passion from beginning, that they are born sellers, they are born entrepreneurs. It for me it was like, let's try something different. I mean, a lot of people were going for masters at that time, during, I mean, in my age circle. A lot of people were joining big companies. I was like, okay, let's give this a try. Nothing to lose on that front. More or less I would gain something or the other, even if the startup doesn't do well. So at that time, they were working on drone based analytics, and I was leading their vision end of things at that time. And surveying, then getting quantitative analysis using photogrammetry is something that we tried on and worked with. Unfortunately, that phase of our startup didn't do well because the laws of DGC at that time were not well formed. Like where to get a drone, or are you allowed to fly a drone? So most of the most of our clients were skeptical a little, like, are you even legally allowed to fly a drone in this space? Or you yourself are a pilot to do that or not? Nowadays, it's very clear that one can get licenses and everything to get down with it. Since that didn't do well, we didn't want to leave it out. And we thought, okay, let's focus on our forte, which is computer vision in itself. And for next 3 years from then, we worked with a lot of different companies: medical imaging, retail, space, then satellite imaging. So it was like a service-based company where we would do projects for big companies, small companies who didn't have in-house expertise in that area. And from there, I mean, the startup is still there. I came out of it. I wanted to explore the product field of things, because service sector versus product sector are two different ball games. So I joined my current company, Flutura, where they are completely focused on industrial AI and defense-based AI, and computer vision is a leg there. And I'm at present, like, the things which I learned after shifting from service to product, I didn't expect such a learning phase to happen, such a steep learning curve to happen for me, but it's going good. So this has been my short journey till now.
Good, good. That's inspiring to hear, Abhishek, because but of course, yeah, we may not compare ourselves with something like Professor Andrew Ng, but
Exactly.
yeah, yeah, but still, I think in our own sense, at least the way you have tried something different apart from a regular job career, I think that's really an inspiring journey. And but I also see that you keep on sharing a lot of very useful resources.
Okay.
I think I'm my YouTube playlist was not saved with so many number of videos ever. After I started following you, I have, it's like it has grown, like there are a lot of saved libraries in my YouTube playlist now.
Right.
So very is is there any specific reason that you do? That's the first question that I have. The
Okay.
another question that I have is, how do you find time with such a busy life as an entrepreneur?
Okay, okay. So basically, I got active on LinkedIn with regards to one of an open source tool that we were preparing in my startup.
Hmm.
It was, I mean, I have a lot of passion towards low code and no code systems, which can make life easier for a lot of people. So there was one tool which we created for an end-to-end computer vision called as Monk. And it's I mean, at this point we are not actively working on it because I came out of the startup, but that was like a passionate thing that I started off. And with regards to selling that off, the Monk as a library, someone in on LinkedIn suggested me that why don't you create stuff using that and start pushing it on LinkedIn, Facebook, and other platforms. So from there, I got a nick of posting things on LinkedIn related to that thing, very particular. Like I would create tutorials in 5 minutes and showcase it like it can be done.
Hmm.
So that's how it started. But later, I realized that when I'm sharing something, when I'm explicitly I mean, I was working on finding out some tool for integrating it to be Monk, integrated it to the Monk. I found that if I have to share, I would be really cautious and try to do a in-depth research on that tool rather than just if I would not share it.
Mm.
So it was like a selfless thing that came up, where if I wanted to share something, I would do a lot of research on it. So in turn, that would help my team.
Uh,
So from there, I started that, and I have a nick of giving tutorials, lectures in colleges. I love teaching, and I love talking, as you can see.
yeah,
So for that, I would do a lot of research. So I mean, that thing stuck in my mind that if I have to learn something, I need to share it.
yeah,
And if I will share it, I'll explicitly go in depth of that thing. So from there, I started sharing video lectures or tools, GitHub open source, this thing, because GitHub in general is a like a beautiful place where you will find answers to everything.
yeah,
Earlier, I mean, if you just think about it, if we will know about PyTorch, TensorFlow, and the big tools, but there are some very great applications and helper tools which are created by different developers. They create it for themselves and they push it on GitHub. So if we are trying to replicate it, it will take a lot of time. So that's why our team and me, we sit on it and we find things, we work on it, and if I like something, I share it.
mm,
So it like, I mean, my time is taken up from the work which I'm doing, and it goes there. With regards to the courses, is something that I started doing very recently, because I saw that there are abundance of resources on YouTube where they do not either come up or they are not shared a lot of times. Most of the times we see the top 10 courses that exist in this field, and not always that every lecture from the top 10 courses is good. I mean, not talking about the lecturers there or the professors there, but some lectures in some other videos are very good. Like one of the case was, I was finding something on for CUDA, and there was a course by ETH Zurich on massively parallel processing systems,
mm, mm,
where I found that the CUDA in itself was very beautifully explained, as well as the other resources where other chapters were very well explained. So from there, I started sharing them. And when I saw a good response on LinkedIn, I was like, okay, let's share more. Because of course, I won't be going through every lecture that I share, but usually I'll go through at least 2 or 3 chapters from there for my purpose or for my teams.
mm.
So this is how it's a mix and match of things that came up, and I started sharing things.
Oh, okay, okay. That's nice, very nice how you are able to link your what do you say, whatever you are currently trying to attempt in your startup, and then
Right.
something your passion or your interest to share out the knowledge with others, right? So I think that's very interesting how you tied up both the things. But how do you find them as such? This is something which is like, is it, if it's not a trade secret to understand,
Uh-huh.
maybe is it what kind of a keywords that you use, or is there any specific
Mhm.
way that you try to find out these lectures?
I think a simple rule: go beyond the page 5 of Google
Oh, okay,
or the
okay,
YouTube. Yeah.
okay, okay.
So basically, if I have to find something, there are 3, 4 places where I look for. First, of course, is the Google page, and I start looking at the respective later pages. Get on GitHub, there are very good researchers who have put things like awesome deep learning,
Mm,
awesome machine learning, awesome MLOps tools.
mm,
So they have collated a list of things uh, on their own GitHub pages, which actually link out to different GitHub tools.
mm,
So if I'm trying to look for, say, something on the lines of differential privacy, or if I'm trying to look for distributed deep learning for our team, I usually simply search for awesome distributed deep learning. Something or the other pops up in the second or the third page, or at times even on the first page itself, where you will get this. Or if you go to GitHub and use these keywords as the search, and sort the things based on the latest commits rather than the number of stars.
mm,
So you will see the active ones which are working on there. And then I usually talk to them, the organizers there or the developers there, and I get a complete idea of what their tool is and things like those. So this is usually my search thing. On YouTube, again, it's on the similar lines. Like if I am searching for a particular kind of a lecture, that lecture, I usually see that is that lecture actually linked to a complete playlist or somewhere.
mm,
So I mean, it's not just about the courses that are coming from the different universities. there are individual YouTubers as well who are creating beautiful content.
Okay.
And the way they explain it is different from way standardized courses in India or outside India are explaining us. So that's the motivation as well, and that's how I simply search. So nothing magical there, just being patient.
Okay, okay. But I like the way you said as search beyond page five. I think that's really cool. Good. So coming to MLOps as a DL practitioner from some time, you have I see that there's a good experience that you have gained in your what do you say, academic and the industrial career in the form of an internships or an industrial experience. So what do you it's like I see different people saying the MLOps framework in a slightly different way. Of course, the fundamentals remain to be the same. But from your
Right.
perspective, what do you think will be the important stages of an machine learning model development as such?
Hmm. So whenever, even when trainees come to our company, or if someone comes to me for the same similar kind of suggestion, I always tell them, like, do not focus only on the mm, algorithm and the model. There is a lot happening from the time I mean, the idea springs up and the time it is deployed. And it's not just about, I mean, I cannot push everything into ML ops as such, but I think this forms a very good cycle that in our company as well we are following these days, where it starts from scoping. I mean, I'll take 5-10 minutes of your time on this to give a
Yeah.
complete idea.
Yeah.
Like, we always start with scoping the project, because when the requirements come from the client, they have to be taken. I mean, they come in a non-AI/ML problem statement. They have a problem, they want it to be solved. Whether it's AI or ML, it's not our case. And this journey, which I'm trying to explain, is something I tell every other beginner as well as expert to take into consideration, and not just the ML knowledge that you have. So basically, when a problem statement comes into play, most of the time our journey goes into, like, we educate the client on how the AI ML process works, because they come with a very stringent software background. So it's a little different from the software thing. Then how it will be solved using AI, and if something is not requiring AI, we actually tell them that, okay, you don't need an AI or ML for that. Go beyond something. Go with a traditional rule-based system. Now coming to the part where the actual thing starts. So once you know that there exists a problem statement, you figure out the best possible way to achieve it. By the best, I mean the easiest possible way. To give you an example, an application was there where we were supposed to detect thousands of smaller pellets of a particular metal. Now they were falling from a height, and when they are falling in real time, we were to detect them and find their sizes. So earlier, the idea was, let's go with image segmentation and work on towards it, and then find some watershed algorithm or something and work towards it. Later, an intern in our company was like, "Why are you complicating things with image segmentation? It's a round something. Go with object detection. And once you get a box on it, it's an in circle, basically. So instead of using a complex segmentation or algorithm, go with simple object detection algorithms. So there we have our sorry, there we have our collaborative sessions where everyone pitches their points, like how it can be solved. In there, four major components come into play. First is scope. What is the scope of things that we need to tackle to? The second is what cannot be in the scope. These are very important because, I mean, if you have an ML model and it's working 98% of the times, versus you have an ML model working 80% of the times and it's actually beneficial to the client, the second one is always helpful in the real world, because nobody cares initially if they are not able to gain anything from it, like monetary gains, the business gains. So scope, outer scope, then comes the assumptions, because at a lot of times the client gives you a picture of things and you assume that, okay, the lighting conditions would be like this. I assume that the angle of the camera would be this. There won't be any rains. Everything that comes to your mind, put it out. It clarifies the problem in the most beautiful manner. And the fourth thing is the requirements from the clients, because at times you might need some data from them, you might need some annotated data from them. You want the domain expertise to come into play. So this scoping is one of the major parts which I think is missing from the MLOps cycle. Because anything that you're creating it for some business. Unless it's a academia project, but then also one needs to show that there is an importance of that. Like simply creating a model won't make sense. So the first part comes the scoping. So in this, we have the entire knowledge of what exists, and this starts our MLOps cycle. Then comes the sort of the development phase of things. The first, when I earlier joined my company, we were having this scenario where there were some 7-8 developers, 7-8 data engineers, everyone having their own style of coding. Everyone is comfortable. Someone is comfortable with, say, PyTorch, someone is comfortable with TensorFlow. And each of these libraries give you different ways of the models. And for me, it was like, I want the data to be at a good place, then the algorithms come, then this comes, and that comes. For someone, it will be like they will just take up a Jupyter notebook and quickly create a prototype. Okay, so with this, a haphazard chaos would come into play where you have something, I have something, I have a model, you have a model. We cannot compare what's happening with that. Your model is better, or my model is better. And it's always like there should be that competitive spirit in a team where if two people are creating two different types of models, they should be able to create the best of it and yet compare it. So then we thought of we should have MLOps in a form of a life cycle management where the data, their versioning, the algorithms, their versioning, the model, its versioning, the hyperparameters selected, and what you are doing post that. All of this should be standardized. So this is where the no-code and the low-code tools of MLOps, like Neptune, then there are a few Optuna, then the logging tools of TensorBoard, then on the lines of mesh TensorFlow, which basically is the distributed training, then interpretability and visual explanations, GradCams, and all these tools come into play, which we keep a resource of and try to work with. ML flow, weights and biases, logging them, right? So going back to the development phase, now we have a lifecycle manager. Once we have the lifecycle manager, we know that everyone should be using the same lifecycle manager for that. And you may have a better algorithm with you, I may not have. So we started bringing in a process where there is a base machine learning management system with us. And if you have to add a new algorithm, if you want to test a new algorithm, you convert your algorithm, GitHub GitHub code or your self-implemented code into the format which this algorithm, this platform is developed for. So suppose you are doing YOLO v5, I am doing efficient depth. Both your networks, both your and my network should have an online wrapper on it, which will serve the similar purpose. Like take in the data, change the hyperparameters, train the model. It's very easy to create low-code systems on this. In this way, 2 years down the line, or say even 6 months down the line, you want to check what I did. Your style of coding and my style of coding is same. So this, according to me, is the MLOps cycle that is very important and is lacking in most of the companies and the places people are working. Because for a single model, you tend to create at least 50 to 60 experiments. Like you will change the learning rate, you will change the data set in general, you will add new data points or use augmentation techniques. Then you will change your algorithms. And when all of this is happening, you will not have a track of which one was the best of those 50 experiments. Like there are 50 Jupyter notebooks and written in haywire manner. So this is something for me, what MLOps is, where you take out different tools from different sectors. For data, there are many tools. I have a list of tools. I just opened up a few list of tools from my end, where ML Machine, Optuna for hyperparameter tuning. Then for model optimization, you have TensorRT, Faster Transformer. Then Intel OpenVINO is a very good tool. Then on the lines of these things, like the tools for no-code systems, you have PyCaret, Apple's Create ML. All these things you bring at one particular place, whichever you want to use. Stitch them together, because don't recreate them. Stitch them together and create a pipeline for end-to-end system. So this is something that we brought, and we saw that our prototyping was like happening in a couple of days rather than taking a week, and our entire development cycle came down to 2 weeks instead of 4 months.
Oh, that's 2 weeks instead of 4 months. That's a very
Yes.
drastic reduction in the time.
Yeah. And the major time that we were spending was trying to understand, okay, what we did in the experiment number 23rd, because now we are experiment number 70th. And was that better, or is this better? So that logging of the operations of every step and working on it is something that we thought of that it would be the best, and we got it. And if you know about this, Google's they have a very beautiful something called model cards, where in that model card they would explain. I mean, it will have everything, every detail from data till it's deployed, with how it's optimized, uh, how what are the hyperparameters selected, what are the validation results on it, like the MAP, the precision recall, and all those metrics. And it also gives where it works, where it doesn't work. So this single model card is good for your developer, it's good for the project manager, and it's good for the salesperson as well, because they now know where they can tell the client that in these cases it might not work, or it might work with a less efficiency. So we got these model cards, and our life has been, I mean, I cannot say how better it has become with those things.
Okay, this model cards is something which is a bit new for me. About it. Yeah, good. That's good to know. Especially the scoping thing, right? I think that is where I believe a very it the for the success of any project actually lies there, I believe, and which is
Right,
what is missing in many of the machine learning projects these days. And
right.
even myself, I'm trying to get better at it now.
Okay.
Good. So I think you have described about the tools for each and every stage just now, right? So for somebody like a beginner in this
Mhm,
field of MLOps, and right, so
mhm,
can you suggest some tools for a beginner to focus on?
mhm.
Say, when I look at the number of tools that are exist for each and every stage of an machine learning model pipeline, right? So uh, sometimes I get scared, right? So which tool to focus on, right? So say from your perspective for a beginner, what do you think will be the right tool for every stage of this machine learning model development?
I mean, I cannot explain it, and I cannot suggest something on the general machine learning space, but for computer vision space, I can definitely walk you through the cycle.
Yeah.
Let's start with the data. So the first thing that would come into play is with regards to the experimental data analysis that would happen with computer vision, right? And there are a couple of, I mean, the best place to do, I mean, learn about EDA in computer vision on any space is Kaggle. So when you go to Kaggle and see the competitors, they will have, I mean, the best competitors and the best, the ones who usually win, they will have a separate notebook or a tutorial for experimental data analysis, where they will have the custom codes, but the typical thinking will be always the same. Suppose it's an object detection system. So they will try to find the outliers, like the images which are very dark, images which are very light, the images which are blurred, which have a lot of noise. Then they move on to the next step where they annotate the data. Say on Kaggle, it's already annotated, but for annotation, one can look for tools like Label Image, Label Studio, and then integrate these annotation tools with a sort of an online learning system. A typical online learning system would be like you annotate the first 10 or 20 images, give it to a few short learning module, and it will start at least predicting and making your life easier for the next 100 images,
Hmm.
right? At least the pace will be faster. So that is one thing I would suggest. Then once the data is annotated, To check the algorithms, which algorithms to use, people start using another set of EDA, which is done for the labels. Like, are your annotation boxes very small? So that means your object tends to be very far away from the image, or they are very big. Is it a mix of things? Is your object always falling in some quadrant in the image? Because say you are going for a drone detection system, your images will be on the upper half most of the times, and you will see that none of the drones are here in your training data set. And when you move towards your testing set, a drone might actually be camouflaged towards the ground, and you are not able to work on that. So this gives an idea of what your data lacks and which sort of algorithms would work on it. There are general typical rules people tend to have, like if the object is very smaller or something, use efficient debts or the YOLO V5 versions of things, which are typically working good with them. Or if the object is very near, like a faces type of a system, go for retina nets. They are very good with that. Then once you know the shortcomings in your images, go with data augmentation libraries such as albumentation. Then there is ImageAug. These are very good libraries which give artificial augmentations to these images, like flipping it or changing the contrast, changing the dark, bringing in more dark images, basically making it ready for generalization, making your data ready for generalization artificially. These days, there are also diffusion models and GAN models which can actually generate that. And we have worked on this where a client gave us a glass image where there was a crack. And the client said that at this point, we do not have any more images where there are actually defective glasses. Can you do something for us? We took that, and there is something called as a SynGAN library, which takes up a single image and creates multiple variants of patterns in that. And we created some 1,000 more cracked images rather than taking up data from the internet. Because in real, when you are working with a client like, defense and manufacturing, you need to be very careful about the data privacy and the copyrights behind that data and everything. So we created our own imagery and worked with it. So this happens with the data augmentation. So now we are done. We have the data. We did a basic analysis. We annotated it using some sort of a tool. Then we did another analysis to find out how things are in that annotation, and we augmented that data. So the data part at least is fixed in this with the tools like albumentation and all that, as I mentioned. Then comes the algorithmic part. We usually like to have an algorithmic bank with us, where if you have heard about object detection, open libraries, or TensorFlow Model Zoo, PyTorch Model Zoo, each of them have their own different sort of models associated. So we like to have a 10 set of bulky models, 10 set of lightweight models, 10 set of models which are based on transformers, a few set of models which take care of image as a whole with self-attention maps, saliency type of an object detector. So all these sort of things, we have like 5, 5, 6, 6, 7, 7 sort of bank. Based on this, we take the data, a bunch of it, and run through each one of them, not every, the ones we feel like these 20 would be good. This gives us a basic idea, like based on initial learning on smaller data, like how much each of these is working better. So now if we boil down to 5 or 6 of them, we are pretty sure that these 5 will be very good enough for us for this kind of data. And you can never be sure that there will be some other algorithm or some other library which will always be better. And that thought in itself used to give us that overwhelming you can call it anxiety. Okay, what if we are missing on something? We just gave up on it. Yeah. So based on this, we will work on it. And then for each of these libraries, we will use hyperparameter tuners. Like there is ML machine as one, this thing. Then there is hyperopt. Then there are something on the tracker tools, which keep track of all your hyperparameters like WN weights and biases, MLflow, polyaxon is another. Then TensorBoard in itself does it. All these things would help us keep a track of things like what's happening. And they even suggest like this is the best learning rate, like fast AI's tool gives you a learning rate finder. So all these things would bring in like a plug and play. That's why it's very important, as I was mentioning, that all the tools, all the algorithms should have a standardized coding for you. Even if it is TensorFlow and that, create a wrapper on top of it so that the code is standardized. Then comes, this is with regards to once your model is trained, we move, I mean, with that as well, if you have to train a bulky model, go with distributed deep learning sort of a scenario where I think deep speed is a very good library there for this thing. Then Horovod, I don't know how to pronounce it, HOROVOD, would be a very good taking your PyTorch code and putting it on top of it, like it's an H2O based system. So that's a very good library. So find out the tools. I mean, for every step, there will be a tool. Then once the training is done, there will be model optimization, like based on the hardware you want to push it onto. Like you can go with ONNX optimization, like in quantization. And then there is TensorRT, which is very good with NVIDIA based systems. And most of our deployments are on NVIDIA based systems only. If you want to go with CPU-based system, then there is CPU quantizations by OpenVINO, Intel OpenVINO, and most of our these things are happening on Intel CPUs only. So based on the type of the hardware, we bring in 2-3 libraries there and work on it. The main part of this when it comes to the deployment, because this is a development cycle and the tools around it. When it comes to the deployment, something we saw was like microservice based architecture is actually important, because one of the deployments we did, we took up a bulk system, a simple monolithic system, pushed it onto the client side. It was handling 15 different cameras for hard hat safety vest detection and everything. Later, we realized even if there is a single memory leak in any of the parts, the entire system is done. And for us to trace out where that error happened, it's almost impossible even with the logging tools present in it. Now, if you have a multi-service based system where there is a collector which takes up data from the cameras, there is a processor which does all the processing, and there is a transmitter which transmit all the data here to logs, alerting systems, and all that. You divide your work into multiple things. Then separate one collector for one camera, second collector for second camera. So you know which point it's breaking. It's like a complete pipeline you have. And like they show in the sci-fi movies, right? There is a red dot pinpointing, okay, this is the point where it's wrong. One of your processors is down, one of your collectors is down. It gives a very beautiful work on this. So for that, good tools would be like to handle the Kubernetes systems or your Dockerized systems would be Docker Compose, then Minikube. Helm is another very good tool to handle these Kubernetes-based systems. So I think this would be my suggestion. Again, a lot of tools I have mentioned. Select one, it does the work.
Okay. Okay.
Any
So,
of these will do the work with some more features here and there.
okay. Okay. Good. And thank you so much for those insights. I think the EDA is something which was very useful, which you have said right here. Probably that is something which will be really crucial in the beginning stages. Very well.
Right.
Right. And so the other question that I had was, does PyTorch or TensorFlow really matters? As in, I see that there are lot of GitHub repos these days are there in PyTorch, and but one of my previous supervisors used to say that TensorFlow is widely used if we really want to deploy our model finally. Right. So,
Right.
but PyTorch was very easy for me to learn, very easy for me to prototype and do the things. It was
Right.
making things faster. But whereas TensorFlow, it was taking time. Is it really important as a beginner to learn PyTorch or TensorFlow, or with something like ONNX tools? Is it can we really what do you say? Need not worry much about whether we are using PyTorch or TensorFlow, and then just convert it into something like an ONNX and then deploy it.
Okay, so I'll come backwards. At this point, like ONNX and the other libraries which are trying to bridge the gap between these are in development phase, and with
Okay.
the pace with which each and every of these algorithms are coming every day, it's very difficult to ONNX developers or their maintainers to keep a track of everything. Because say a new algorithm came into play which has a very different type of attention network, your ONNX will not support it. And then we are at the mercy of the actual creator of that algorithm. If they use TensorFlow, we will have to use TensorFlow. If they use PyTorch, we'll have to use PyTorch.
Okay.
So that thing has happened with us as well, where what we did is, I mean, this is something we call as collaborative learning, where half of our team knows PyTorch,
Mm.
half of our team knows TensorFlow.
Okay.
Okay, and if and these the TensorFlow team will be working on. I mean, it's not a very big team as such, like four people at this point. And the TensorFlow team will be looking at the new algorithms that are coming there, and this we do a benchmark analysis. And I mean, your professor, as you mentioned, is one of the professors, as you quoted, is actually right. When it comes to TensorFlow, it's easier to coming to deployment because of TensorRT,
Mm.
and that bridge is now being that gap is now being bridged by using ONNX as the module. Then one of I think one ML it's called, or one DL it's called. It's a like organization which is trying to bring in everything as a one consortium sort of a scenario, like an ONNX but a better version of ONNX.
Okay.
So there, I think it's one cannot learn everything, but if you have a team, you can push it. Like some people are very good with PyTorch, some people are good with TensorFlow, and based on the algorithms that you're trying to do an R&D on, you can see the speed difference, the memory efficiency difference. Because in the end, it's also about new layers being coming into play with a new algorithm, and that author might not have utilized the utmost potential of TensorFlow while writing it, so their algorithm is slow. But PyTorch, the same implementation in PyTorch, someone used that and it's working fine. So at times it's not about the library as well, but about the developer as well, who created the team which created that algorithm.
Okay.
So this collaborative learning has helped us in a way, like half of our team knows Docker, half knows Kubernetes. We merge things up. And it's
Okay.
impossible to keep a track because it gets so overwhelming and depressing at times that this person knows so much, I have no knowledge about it.
Yeah.
And you start doubting yourself. And this happens with our team a lot of times. So this is where we started off a year ago in this collaborative learning.
I think that's really interesting, and it's very useful to have such kind of a collaborative learning. I think
Right.
more and more we work in teams, even in academia. I think this kind of a collaborating learning can be implemented and it will be very useful as well.
Right.
Yeah. Good. So, right, so we have spoken a lot about ML model development
Hmm.
at each and every stages. You beautifully spoke about the tools that can be used at each and every individual stages. This one problem which I started working on was on this data drifts, right? So,
Okay.
how
Right.
to improve the model performance
Mm.
when there is a data drift out of distribution generalization is something. OOD generalization one
Right.
of my research topics actually. Right.
Okay.
So, but as a TL practitioner, what from your point of view, what are the different kinds of data drifts that we can expect in the ML
Mm.
model deployment? And
Mm.
can you please suggest us some insights on how can we overcome them? Some of the common
Got it.
insights that that a beginner can experience and how he can overcome those data drifts.
Got it. Got it. And I actually got this idea that you are working in this field from the paper that you shared recently that it got published.
Yeah, yeah.
Congratulations on that as well.
Thank you, thank
So I was going through that. I just got through the synopsis and I understood like you are trying to solve it even before it occurs, if I'm
you. Yeah,
not wrong.
yeah,
Right.
yeah.
So uh, for us, on the industrial level, like on actual implementation level, not on the research level, one of the very recent explanations, I mean, stories that I can share with you is with regards to the I told you, right? There was a use case where we had to detect these metal pellets falling from the system.
Mm,
So those are basically iron ore pellets,
mm,
where they are being pushed into a pelletizer and then taken out so that it can be pushed into, converted into elemental iron using blast.
mm,
Now, when we deployed our system, when we first went there, we saw the entire scenario, the kind of dusty environment it was, the kind of lighting there were, and everything. A point where we missed out on understanding was, what if it is cloudy and sort of a scenario on the day part, and what if it's the lights are not very well working at some certain point during the night part? What do we do at that time? So once we came back from there, this after having this discussion, we used synthetic data generation to create such synthetic scenarios for the images that we had collected and worked on. Everything was going good. Suddenly, at the time of deployment, the chemical composition of the iron ore grade that was being used was completely changed. And once that changed, the dust and the heat in that system was like humongous. I mean, even with normal eyes, I wasn't able to see what's falling from there.
okay.
So these are the kind of drifts, or you can say unknown scenarios that come our way. We don't usually call it a drift, we call it like it's gone.
Okay.
So, with regards to such scenarios, our work methodology has always been on the lines of incremental learning. Now, most of the times, what we do is, at times, as soon as the model is deployed, our models are always fitted with human in the loop relabeling and an incremental learning. So our team is always there for a couple of months, and as soon as the scenarios changes, to keep a track of what the results that we are getting, because the client does not understand, like, is there a box around it or what's happening around it. They just want the metrics that they are have asked for. So our team sits there, reannotates the data. We try to bring in more synthetic scenarios using GANs and other simple augmentation techniques, and then push it back to an online learning system. In that online learning system, one thing that we have noticed is we keep that learning very minimal, like the learning rates and the other changes that the model has to take up to be very minimal, because at times such cases would be one off, like a very shiny or a very sunny day or a very gloomy day. These are very one-offs and these don't happen. But changes in there, based on, I mean, just because such a scenario happen, if we drastically change our model, we have seen that the model's performance overall as a generalization decreases.
Mm,
And we could not find much literature on such scenarios happening, because it's a thing which you experience and see. Like, such a thing happens, and it's simply that you need to work on. Then, as I mentioned about the dust case scenario, we then started looking into GANs which would remove out the dust from the images. So it's always been incremental on our way, because initially, if we assume something and bring in a very bulky system to the client, the hardware cost just shoots up.
mm,
And that becomes a direct no for the client initially, that if I say that if I want to deploy a prototype and it will take around 50K USD for you to invest on the hardware, it's a simple no. Like, it's a big investment and it's a prototype. So once that trust is built, we then go with adding on modules based on the learnings that we are finding. But just before that, and I mean, the kind of paper that you have published is something that even we need to look into. But no, I mean, till now we haven't used anything that would take care of most of the scenarios even before we deploy.
okay. Okay.
And the major reason is cost, because we have to be cost effective as well, like a trade-off between accuracy and cost. So that is the case. But I'll definitely look into such systems as well.
Okay, sure, sure. So our scenario was mostly like when the data is generating from multiple different sources, then how do we
Right.
minimize the what do you say, the source specific information and enhance the source invariant information, basically. That's the
Right. Right.
kind of problem that we are working on. And source specific information can come in multiple different ways, like illuminations, or the
Right.
object can be different It's like it can be
Exactly.
visualized differently in different sources of the data.
Right. So just to add on to that, I mean, since you mentioned about the source, most of the another scenarios that we see is the client changing the camera model or the camera manufacturer. There is a new cameras being added, which have no correlation with the data that was coming earlier,
Hmm.
and new types of defects coming into play. Suppose, I mean, we work with manufacturing companies. Now I am working with a kind of scratches that my model has trained on, and suddenly they change their material and a newer type of cracks are being seen. So either they are overlooked or they are, false positives are detected. All these things definitely happen in our space. And for us, it has always been incrementally increasing. So this is where in the scoping part, I mentioned that we educate the client on the process. It's not a off the shelf one-off system that we are giving to you.
Hmm.
So like that's why the link from there to here.
Yeah, scoping plays a very important role, right? So
Yeah.
how we interact with the customers and everything first, so as to design the model in a very optimal way, I believe. Good. Good.
Right.
I think these were some of the questions that some of the researchers with whom I was interacting with
Okay.
before your call, and these were the questions that they have posed, and I think I got the answers from majority of them, and it was a good learning for me
Okay.
as well to learn
Thank you.
from your experience. Thank you so much, Abhishek, for your time. I think, if possible, maybe I think I've taken around 50 minutes of your time now. So,
No
if
worries.
possible in future, we would like to know as you were mentioning that it's very important that we need to have a structured way of programming, right? So
Right.
that so that it fits in at every stages, it fits in with the tools in every stage of a ML model development, right? So maybe
Right.
on those lines, if this is something is not what do you say confidential to share, or if something can be done on that side, maybe I'll research more about it and then come back to you and do another podcast session with you on those lines.
Definitely. Because I mean, I'm actually writing a book on the same, on the structured way of writing a computer vision system with stories from different individuals as well, and trying to create a more application oriented book. I think by Jan mid, I should be able to release it. Let's see how it goes up.
That's brilliant. I'll order the first copy, Abhishek.
Thank
Yeah.
you. I
So
mean, I
that,
actually wanted to check on these lines, like,
yeah,
will people be interested in buying that? But I'm
definitely,
seeing good
definitely.
traction towards it.
Definitely. I think I would like to buy the first. Do you are you keeping it Amazon so that it has an international shipping?
Definitely, yes, definitely. That's the idea. Earlier, I was thinking to keep it online directly, like this thing, but mine, as personally, I like books in my hand.
Okay.
So both the ways I'm trying to figure out how to push it forward.
Okay.
And one more addition that I'm trying to do is getting stories from different individuals, not the the director level people, but the manager level and the data scientist level people like me, who actually go through these every day and they have their different insights which don't really come out.
Mm.
So just trying to figure out how to push that in as well.
Oh, okay. Okay. Sure. Sure. I think please let us know. We would most of the research community who continuously participate in SciTech talks,
Hmm.
they would love to know about your book more as well. Yeah.
Sure.
Yeah, sure.
Yeah.
Thank you so much, Abhishek, for your time. Looking
Thank you.
forward to connect with you soon again on another topic as well. Yeah, thank you.
Sure. And thanks for having me in your podcast.
Yeah, thank you. Thanks, Abhishek.
Thank you.
Bye.
Bye.